Hi everyone, welcome to this new video. In today's video, we're gonna continue working with model inference, specifically online inference. So in the previous video, I showed you how to build a very basic inference server, local inference server using Fast API. And in today's video, we're going to do the same but using MLflow. So let me go to the folder under examples, under iris classifier. I have this script online inference, and here I have basically the code that I have implemented to test the endpoints. So the first thing that we need to do to run the local inference server using MLflow is to have a model available, right? Because the command that we need to use to run the server is this one, right? MLflow models serve -m and specify the model array. As you can see here, I'm using the alias notation to indicate a production model and the environment manager, which in this case I'm using local, so I can use this local BNB. You can use UB, PyMB, but in this case I'm going to specify my local virtual environment. Now there are more parameters that you can pass here, like the port, the host, etc. But I'm going to use the default values for those ones. Now, as you can see here, we are assuming that there is already a model registered in the model registry. So let me run this command to start my local inference server. And remember that with Fast API, we needed to write some code. With MLflow, we only need to run this command. And of course, have the model available in the model registry, which is something that we needed to consider in both cases, Fast API and MLflow. And it's done. The model or the local server, it's using the local machine and this particular port, which is a default value. Now let's see how we can use this. MLflow provides 4 endpoints: invocations, which is the endpoint that we need to use to get the predictions. PIM, health, are endpoints that we can use to verify the status of the server. And version returns the version of MLflow that we are using, or the MLflow version, right? So this function, MLflow endpoints, implements some logic here to run these endpoints. So first we define the base URL. Then I'm creating this dictionary with the endpoints, right? Notice here that I am using the base URL and invocations, right? So I'm combining these two things. And then here I have some logic to pass the endpoint name using the CLI. And finally, I'm using the get method, right, to make the request. So let me go to a different terminal and run this. This endpoint can be found in the pipeproject.toml file as iris clf serving endpoints. So I'm going to run poetry, run the name of the entry point, and let's say version, right? This will return the MLflow version. Okay, yes, 2.2, right? Now let's say that I want to check the health on the server, and we should get something like 200. Okay, yes, this is the status code, which means that everything is okay. And finally, pin, which is the same as health, should return 200 to indicate that everything is okay. Okay, this is just to verify the status of the server and the MLflow version that we are using. Now let's take a look at the invocations endpoint. This is the endpoint that we need to use to get the predictions. To use the invocations endpoints, we need to consider the format that we need to use to pass or to send the payload, right? The data that the model will use to get the predictions. So there are mainly two ways, let's say, or mechanisms that we can use to pass data, right? And the first one is using CSV format, right, or content. In this case, what we need to do is to specify the content type in the headers as text CSV, right? Because we're going to pass a regular CSV. And then make a post request, right, to the URL. And notice that here the URL is defined using the invocations endpoint, right? So I'm going to print the payload, only the payload, just to show you how this looks like. It's just a CSV format. So I'm going to go first to the entry point, to pyproject.toml. I'm going to copy this name. And now here, going to run the entry point, and we're going to see the data that we're going to send. Yes. So we have the columns, the column names, right? And the values separated by comma, which is what means CSV, right? Now, what I'm going to do is to make the post request to get the predictions, right? So I'm going to uncomment this. And I'm going to explain a bit more about the code. Okay, we define the headers, text CSV, because we are sending a CSV data. The URL is defined using the invocations endpoint. Then I make an API request using the post method. It's a post request. I specify the URL, the payload, and the headers. Now, if the status code is 200, which means that it was successful, I'm going to get the predictions key, right, which is what I get from the response of the server. And then I'm going to use the predictions to build this data frame, which compares the predictions with the labels. Remember that here we're using this get train test data to get the data or the features, right? So from this method, we get the features and the labels, because this is a dummy data set. So we have the labels available. So I'm going to run the entry point and see what happens. Okay, what happens here? Okay, I didn't save the change. So let me save. And let me see what happens. Okay, we get the predictions. And since this is a dummy model, well, they are basically, this is a perfect model, basically. So let's talk about another format that we can use, and it's basically the JSON format, right? So in this case, well, I don't want to make this video too long, so I'm going to talk about this, let's say, format in a different video. But for now, that's all for this video. Thanks for watching it, and see you next time.